This is it, the last update I'll do for a while. It's really tiring to teach coding in a big project like this where everything is connected, so I need some rest and we'll be teaching easier things for a while. But now, let's add some finishing touches to the game. We'll play a bit with the styles, show the cars on a minimap. I'll teach you another way to handle collisions so it's not game over if we just touch the wall a little bit. And last but not least, how to make the car look like that. Start your editors and get ready for one last ride. Get it? Because I'm gonna take it easy. No, 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 no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Today I'm gonna work with the Race HTML version because using the keyboard is much more convenient than some crazy thing when testing. And we're gonna do fine tuning starting with showing somehow where the cars are because now I'm in third place, but I would like to still see something in the game indicating that other than this list on the right. So I think that showing the cars is too striking because it will look like they're obstacles. But maybe showing the shadows at the bottom is enough. Let's see. Let's open camera.js and where we get the polys here, we'll add the shadows like so. They will be just the bases of the cars. So the car poly essentially. We don't need to extrude those, just to filter. And here I'm going to remap all the cars like we had at some point before so that each car just becomes a new polygon from its polygon. But here, these points are not real points, they just have x and y values. So we are going to do this and create new points when creating this polygon. So everything still works. And now let's add this here so that we get the shadows as well. And if we save and refresh, we should see them appearing like that on the bottom, and it's definitely much better, but still quite striking. I think I would like them to be somehow barely visible so that I can still see that they're there, but they don't really disturb me in any way. So let's see if we can style these things. I'm just going to go and loop through all of the car shadows like so. And for each poly, I'm going to give it two attributes, a fill, and let's give it a transparent black and see how this looks like. And I will remove the stroke. I don't want strokes for these objects. So I'm setting it as fully transparent black in this case. And now these do have new attributes, fill and stroke. But if we go in the render method, we see that the polys that we get here are remapped to new polygons entirely. So we lose those attributes here where we're doing the drawing. And I'm going to fix that by just removing this and replacing it with a new for loop where I'm going to use an index like this. And these polys and proj polys, they are in sync. So here we are going to take the fill and stroke from the polys of I and draw proj polys of I on the context with this fill and stroke. Save and refresh. You see now those shadows are really dark when they're overlapping like that. I don't know if I really like that. But like this, it's quite okay. I mean, I'm not going to try to avoid that when racing. It's really fine. To not have everything dark like that, we have to use here just a gray color and remove this transparency. So maybe it wasn't a good idea. I'm gonna set it to 100%, and here let's try 150 for red, 150 for green, and 150 for blue. Save and refresh. And yeah, this looks pretty good, I think. Now, what would be nice is to see this car that is leading right now also on the minimap. So let's do that next. We have to go to race.js. And now we define the minimap here, but we should do it after we have the cars. So maybe here below the camera, and pass these cars as well to the constructor so that it knows they are there. And let's open the minimap and store these cars as attributes here as well. And now in the update method, after we draw this graph here, I'm going to loop through the cars and just draw them as small dots. Let's begin path, and I'm going to use the arc method at cxcy. And here we were scaling so that we can control the zoom level of the minimap somehow. And we have to do the same. So maybe I want it to be a radius of 5, but I have to divide by the scalar like that. And full circle, so 0 to 2 pi. And let's fill. Save and refresh. And nothing shows now because it's overlapping here, but you can see as they are moving, they are progressing there. Those are individual dots, but not so well visible. Let's make them more visible somehow. Maybe we are the blue car and those are gray shadows. So let's try to set the fill style to gray and see how it looks like. Okay, they are actually a little better, but I would like to draw an outline for them. So maybe we add here, let's set the line width also relative to the scalar, and here do a stroke. Yeah, now they are white. Okay, the outline is white. Let's see how it looks with black outline. I liked it better as white, so let's remove the style. Yeah, this is definitely much better. Now, when driving here, it's a little bothering that that minimap shows the full graph, even though it doesn't appear anymore in our new visualization here. Like the road now to the right is missing. And in a racing game, you shouldn't see these options. They are confusing. So I'm going to keep the corridor path and pass that to the minimap. I think it's clearer in that way. We go to race.js and we get that corridor here. So we need to move this minimap again down here. And this expects a graph. So let's create a new graph, minimap graph from this corridor. So new graph, no points. I'm only interested in the segments because that's what this minimap is drawing there. So passing here the corridor skeleton like that should work. Save and refresh. And now you can see this is much clearer here. Maybe the zoom level can be different now. It would be great to have this in decided in a smarter way, but let's just see how it looks like with this value. And this is better now. I see more detail there, and I can still tell that there is a turn coming quite early on. One thing that you'll see in most games is that the minimap rotates as well according to the car angle. So let's go back to race.js here. And when we are doing the update for the minimap, we can also make the minimap canvas style transform equal to rotate. And let's add here my car angle in radians. Save and refresh. And now you can see that I'm always going up in that minimap. So it's somehow easier to read. For me at least. But if you don't like it, then up to you to choose a better way of visualizing it. Now, this gray background is kind of boring. Let's do something about that. I'm going to go in Style CSS here, where I have these other canvases now. And I'm gonna add the style for the camera canvas as well. The background, I'm gonna set it to a blue color, light blue. I kind of like how one color could be enough to show all this, but it's too much blue and kind of boring. So let's try using a gradient from white to blue. So let's change here to background image. And now a linear gradient from that blue to the white. It's going to look like that. Much better already. And if you don't like it, you can control it a bit more. Like now it's spanning here the full 100%, but maybe you want this blue to start a little bit higher up, like maybe 70% here. This is nicer, I think. Now, when driving, it's a little bit bothering when those buildings just appear like that all of a sudden. For me, it's kind of confusing that they are so striking there. So maybe we try to make them less emphasized. I mean, we don't really care about the buildings. They just give you something to look at around the track. I'm gonna go in camera.js, and here let's do the same thing for the buildings as well. I'm going to copy this part and replace the shadows with the buildings here. Not really nice as such, but maybe if we play with the transparency, like 0.2 here, and let's add strokes here as well. I kind of like that effect. Yeah, this is much better, I think. Not as strong as we had previously. But I would like to have them fade as they are going in the distance here. And we could do that when we do the rendering here. Based on the distance, we can set the global alpha. So let's first calculate the distance from each poly to our camera. And then the global alpha is going to be 1 minus the distance divided by this range. And now the further away things are, the more transparent they become. You can tell here on the road borders that this is more transparent than here. It's better, I think so, but I would like it to be more extreme here at the end. So one way to do that is to wrap this in parenthesis, and then use an exponent here, maybe raising to the power of 2. Okay, I kind of like this already. Yeah, this is really nice. I like what I see. Maybe this car is a little bit too in front, especially when I'm going fast like that. I feel like I could control it better if it's more up close. So let's go here and say maybe 130. Okay, I think even closer it's possible, maybe 100. Yeah, something like that. But it's still escaping quite much there. So it's going too much in the front, I think. Maybe this could be 15%. So the camera is going to stick closer to the car in this case. Yeah, I think this is much more controllable than before, actually. Play with these and figure out what works for you. Now, this color coding here is quite silly now. It looks like a Christmas tree. And I think we can just use white for all the AI cars. So here where we are drawing these statistics, let's replace this with depending if the car is AI or not. If it is, we are going to use white. Otherwise, we still use the car's color. Maybe you want to change your color, and I don't want to hard code blue here for no reason. Yeah, this looks much nicer, I think. We can also remove this scroll bar. I mean, who has time to scroll when the race is on? So going to style CSS, and in the statistics here, let's just set overflow to hidden. And now it's much better, I think. I think that what... Okay. I would like the collisions to not be so rough. Like now it's basically game over if we are touching something. So let's do a basic collision handling here. We'll go in race.js. After we update the car locations, we are going to handle the collisions right here for all the cars, not just us. So AI cars will do better as well after this, hopefully. And let's loop through all of them. And if they are damaged, then let's handle the collisions with the road border. Again, I don't care about collisions with other cars. And we implement this function here above animate. So handle collision with road border for a given car. The first thing we do is find its nearest segment from the corridor skeleton. So that's going to tell us how to correct its position if it's damaged. You'll see. Now we do that with the get nearest segment from the car location and the world corridor skeleton. And for each point of the car polygon, we are going to calculate a correction vector. Maybe I'm going to call these correctors like this. And let's just remap each polygon of the car. Each point of the car polygon, P, we get its projection, its projected point on that nearest segment, like this. And then I want the vector that starts at the original point and ends at this projection. So that's going to tell us how to fix the car's location so it doesn't go outside the bounds. And it could be that more points of the car polygon are outside of the borders, especially if you're gonna go really fast and then get damaged. We're only gonna worry about the one with the maximum magnitude, the one that is furthest away from this corridor skeleton, basically. So let's take out the maximum value from all the corrector magnitudes, like this. And now let's find that corrector with this max magnitude. So I'm just going to use the find here and look for the magnitude that matches our max magnitude. And let's use this corrector to update the car's location on the X and on the Y. And we need to say that the car is not damaged anymore. Now, this should do something. Let's see if I'm going to drive a little bit and hit the wall, maybe here. It sure did something. Well, that vector, that corrector that we are using shouldn't be used with the original magnitude. It should be normalized so that the car is only moved a little bit. I'm gonna go here and calculate the normalized corrector using the normalize function like this. And now let's pass this one here instead. It kind of bounces a little bit. Yeah, this is pretty good already, much better than what we had before because I don't have to restart the race when I get damaged, but I do get stopped in my tracks like that. So it's quite a severe penalty, I think. And oh, something interesting here is that if you continue to push forward in a place like this where you have the end of the road, you can actually go through it. But it only happens here at the end of the road, and now I'm going in reverse, because the projected point on the nearest segment here is actually the projected point on the line. So the segment ended already, and this is not now projecting here. It's projecting still on the last line here. So basically, it's not pushing the car back in that direction. We need to fix that. And it's quite easy. We just take here the full result, so the projection. And now let's calculate that projected point in a better way using the offset as well. So if the offset is less than 0, then we use the first point of the segment. Otherwise, if the offset is greater than 1, then we use the second point of the segment. And if the offset is between 0 and 1, we do what we had previously. Let's save and refresh. And now this should be pretty much the same as before. I can't push outside of this region no matter what because my speed is reset to 0 there when I get damaged. And here, when I'm pushing now, it does force the car back towards this point, not just left and right on the projection on the line. It really uses this last point of the segment to fix the problem. You could do more crazy things here, like now when we are hitting the wall, maybe it would be good for the car to kind of rotate like this a little bit. Let's just see that how to do that, and I'm not gonna go too deep into this because it starts to be physics, and I don't want to change the physics too much in what we have at the moment. So depending on which corrector we are choosing here, the one with the max magnitude, we may want the car to rotate to the left or to the right. And checking that is quite easy. If it's the corrector of 0, it means that it's the front right point of the car. Or if the corrector is the one at index 2, that means that it's the rear left point of the car. In both of these cases, if they touch the wall, we want the car to turn left. So in our reference frame there, left means we increase the angle in a positive way. Let's just say here 0.1. And otherwise, it means the other points are going outside. And then we do a decrease of the angle, like so. Now save, refresh, and let's see if this does anything. I'm gonna go here. Yeah, you can see the car gets corrected somehow. And I could actually, I don't know if I can finish the race, but you could drive like this, like not turn at all and just wait for the system to fix your path. But you're not gonna have a really good time, I think. Actually, this AI here now, oh, it went back already. It look at this time, this 18.2 seconds. It's doing so much better because when it touches the border, it's not the end anymore. Let's try to make a nicer looking car next. And first, I want to fix these kind of small spikes that you see there when drawing these polygons. They happen because when we draw the polys here, we use the default line join, but we could specify a round join like this. Now save, refresh, and you can see that these are much more sharp now. Everywhere, really, all the polygons are affected. And let's now draw the car in a nicer way. So here we won't just extrude and make that kind of box appear there. We will have extrude car. And this here is going to be a single polygon now, the base of the car pretty much. So I'm going to go here and say I want just the first result of filter, which returns an array, but we are only interested in the first one since we only draw our car nicely, not everything else. And this parameter here, I don't need it. I think that the car will have more options there, more parameters, and it's going to know its height and things like that. So maybe not specifying it here like so. Now this extrude car function, I'm just going to copy extrude from here. And this is a single poly now, so no need for this loop anymore. Let's just remove it. Align this better. And these extruded polys, we can actually just return here that value, this combo. We don't need the variable anymore. I think it simplifies things a little bit. So that. Let's remember to rename the function. So this will be extrude car. And do a quick test. I'm going to put here a bigger height just to see if what we did so far is working. Save and refresh. And it's definitely a bulkier size there. Okay, now before we do more styling here, it makes sense to name variables in a more meaningful way. Like, I like to keep each point meaningful somehow. And for example, the front right point of the car is going to be a new point. We're gonna also convert them into our point objects this time. And this will be the poly points of 0 x and poly points of 0 y. Now I don't have to explain to you all the time that this is the front right point. It's clear from its name. And we can do the same with all the others. So this is going to be the front left, and this is point 1. And then back left, and this is going to be point 2. And back right, this is going to be point 3. And using these, we can create the actual base. I think this is much clearer like so. From these points, the front left, back right, and front right. So now the ceiling is formed from these base points, and everything here really is related to this base. And when you look at what the base is, it's explained right here. So much better, even though we are writing a lot of new code here. Now I want this base to not touch the ground like now. All these points have a 0 z value. So we could do that by specifying here how big the wheels should be. I like to define that by the wheel radius, like this. Let's say it's going to be 5. And let's just go here and loop through all of the base points. And change the z value by the wheel radius, like so. Now if we save and refresh, you can see the car is floating there. Okay, nice. Now let's try segmenting this. I'm going to cut it like so that we have a front part and the back part. We're gonna need 2 points for that, one in the middle left, and it's gonna be the average of front left and back left, makes sense. And then middle right is the average of front right, back right. Now let's add these points to our base. Between the front and back left here is where the middle left is going to go. And between the back right and front right is where the middle right is going to go. Save and refresh. And you can see now this vertical line here. So the front part and the back part are 2 different segments here. And we can go on. For example, we can have a quarter front left point, and this is going to be the middle between the front left and the middle left. The more segments we do here, the more control we have over the shape of the car. And I think we're gonna stop with this. Let's see how it looks like. But dividing it into 4 sections from the front to the back is going to give us a lot of control, I think. And let's see where these points fit in. So front left and middle left, this is where quarter front left is, and then middle left, back left, this is where quarter back left is, then back left, back right, middle right. So quarter back right is here, and the last one we have quarter front right. Much easier to do these kind of operations now when these have names rather than if these have that kind of stuff there. Really try. If you don't name things like so, you will have a hard time understanding what this code is doing and updating things like that. Something that takes few minutes can easily take hours. Believe me, I've been there before. Save and refresh. And this is now the segmented car here. Let's control a little bit these top points of the ceiling to give it more of a car shape. For that, I would really like to know which point is which from the ceiling as well. So they will come in the same order, but using here things like ceiling of 1, ceiling of 2 is horrible. And I'm just going to copy this part here, like so. And let me add a comma here at the end. And now do a multi-edit. So I'm going to change all of these lines and define new variables for the ceiling points. I say const c underscore and then the same name, so c for ceiling. And now let's go at the end here, remove that comma, and now it doesn't cut the t from this last line here. And then we can say is equal to the ceiling points of 0. And now let's update this to 1, 2, 3, 4, 5, 6, 7, 8, 9. And now working with these points is going to make a lot of sense. So what I want to do is lower the front points, for example, and I'm just going to say front left z, let's say plus equals to 5, and same for the front right z. Let's save and see how it looks like. So you can see this front just lowered down like that. And let's try changing the others as well. So maybe the quarter front left is also going to go down, but by a smaller amount. And same one for the right. So both of these are now lower here. And let's do it for the back as well. Maybe we're going to use 4 here. And now these points are lower as well. This looks okay. But where is the ceiling? It's actually here. And let's look at it a little bit closer. I'm going to remove these sides for a moment. And this is how it looks like. Maybe not exactly how you expected it to appear, because it has this kind of crazy looking shape there. It kind of looks like a flying carpet when I'm doing this. You can do so many creative things with this code base. It's crazy. But yeah, if we add the sides again, some things here just don't make sense. We would like these to be individual parts like that. I'm going to go after we have the sides defined there, so here, and start defining those ceiling parts, rectangles, basically. Normally, 3D engines use triangles because 3 points define a plane perfectly. If you have rectangles, then they need to be in the same plane for this to look as you expect it to be. And now they are, so we can use them here. No need to divide too much. So the front is going to be front left, quarter front left, and then quarter front right, and front right. So this is the front hood, basically. And let's copy this 3 more times here we start now with the quarter front left and then middle left, middle right, quarter front right. That's kind of like the windshield. And this part, middle left, quarter back left, quarter back right, middle right. That's like the top hood. And the rear windshield and the back of the car are the final segment here. So quarter back left, back right, quarter back right. And we need to add these instead of the ceiling now. So let's spread the ceiling parts, save and refresh. And now the car looks like that. Better already with these new curves, but I would like them at the top to curve inward as well, but not at the bottom. So somehow I would need a midline dividing the car as well. Let's do that next. Where we are defining the ceiling here, I'm just going to copy that. And let's rename this to midline. This is going to be just half the height here. And now when doing these sides, we will have some sides on the bottom section and some sides on the top floor, so to speak. Let's copy this. And the sides at the bottom will be from the base to this midline now. So these will become midline. And these will be the sides from the midline to the ceiling. So all of these get replaced with midline now. Like so. Save and refresh. And there you see the levels appearing now. And to move these inwards on the top, we move them in pairs. I'm going to implement a helper function because doing it here would make this already long code unmanageable, really. So it's going to be something like this. We will have a private method called move inward, and we just say which ones we want to move inward, like the front points, and then move inward with the quarter front left and quarter front right. And then we move the middle points, so middle left and middle right. And then quarter back. These are all ceiling points. That's why they start with the C underscore. And the last one is the back left with the back right. And this move inward, we can define it, for example, down here. Move inward P1 and P2. And the amount we want to move inward is going to be a %. Let's just have a default value for it, like so, and see if we can use it everywhere. And define new points for these. So new P1, we lerp between P1 and P2 by this %. Simple enough. Same thing goes for new P2, lerping between P2 and P1 with this %. And now we replace the values. So we replace the x of P1 with new P1 x, same for the y, and for P2 and new P2 as well. Save and refresh. And it looks okay. Let's see what happens if we use a more extreme % here, like maybe 0.3. Okay, now this transformation is definitely visible. But I don't like that these ceiling points in the back and the ones in the front are in the same plane Everything is the same plane here. So I would like this and the front to move inward as well, like that. On the right as well, obviously. So let's go here where we're moving inward and do a little bit more. The front left and the back left. And I don't want them to move as much, so maybe just 10% is enough. And the same goes for the right side, like this. Okay, it's a little better, I think. This bottom part looks really rectangular, because it is. And maybe we can make it a little bit rounder here, like if we move these points inward and the ones in the front. Let's see how that looks like. We do that on the base points. So up here, after we define these base points, we can move inward the front left and the front right. Let's try 0.1 and do the same thing on the back left and back right. Yeah, this is interesting. I can't really see the car well from the sides, so I'm gonna make this camera not follow the car for a bit. Going up here where we do this move, I'm just going to not do anything. So let's return here like so and refresh. So now when I move the car still goes places, but the camera doesn't follow. Yeah, it's not bad. Maybe these front points can be lower, I think. Let's try here maybe 7, maybe 6. Okay, this is okay. Maybe these front points here could be closer as well. Give it a little bit more round tip than what we have in the back. It's also important to remember that when we do this, it kind of gives a false impression because the shape of the car is still a rectangle. To get these to affect with the collisions, you would have to change the polygon of the actual car. It's not rocket science, we just do the same things there instead. Probably the whole polygon should go there, but I don't want to go there because if you want to make a 3D game, you make a 3D game and these would be 3D models. Here I just want to show you that with a little bit of math, you can do surprisingly many things. So the front left and front right, let's try 0.2. Okay, I'm quite happy with this. All we need is the wheels, and I'm gonna leave this to you as a homework and fast forward this part. This is what I managed to do. So the wheels are there and they are spinning and turning, and I'm really happy with the result. Let me know if you have questions when you look at the code. I'm gonna remove that return from here so that the camera does follow the car. Let's see how this looks like now. Okay, feels really nice. Somehow that shadow on the bottom is bothering me now. Let's try to make it not so striking. Maybe put here 22, 22, 22. Okay. That looks fine, I think. Let's try also changing a little bit the car. Wow, those other racing cars are so fast now. I wonder what happened to this one. Oh, wait, this other one is overtaking. Okay, let's make the geometry a little bit different. Maybe if we lower the height, see how that looks like. So extrude car, the default parameter here. Let's try 15. Oh, okay. This looks much more like a racing car, I think. Awesome. This feels so great. Wow. And might be my personal best so far. I'm not sure, I didn't keep track. I hope you liked this course. If you did, please remember to like and share it with others so they can learn as well. Stay tuned for the live stream coming up. Thanks for watching and see you guys.